Now we're ready to start working on the most basic level of our neural network called the neurode. And we're going to do this over the next 3 assignments with a series of inheritances culminating in a multiple inheritance. But we'll start with something called a multi-link node. And the multi-link node is going to be inherited from something called ABC, which is our abstract base class. We don't have to code this base class, it's already done for us, but we do need to import the ABC module. Multi-link node is going to be an abstract base class, which means that at least one of its methods is not going to be implemented. We'll have the method signature, but we'll have a decorator that says abstract method. We can't actually use multi-link node until we inherit the class into a subclass and implement that missing method. So with this week's assignment, we will also create a subclass called neurode. And neurode is based on multi-link node. In our next assignment, we'll create a subclass of neurode called feed-forward neurode. And then in our third assignment of this series, we will create another subclass inheriting neurode called BP neurode, or backpropagation neurode. The feed-forward neurode class will give us the capability to present a sample, run it through the neurode, and get an output on the other side. The backpropagation neurode class will be used after we've already passed a sample through feed-forward neurode, and it will be used to adjust the weights of the neurode after we see how well the network did at coming up with the right output. Then we'll do a simple multiple inheritance of these two classes into a single class called feed-forward backprop neurode. The multi-link node class visually is going to look kind of like a big spider. It will have several input connections coming from other nodes, as well as some output connections going to other nodes. Notice that this particular spider doesn't have to have the same number of legs on each side. The class will have some internal variables, num inputs. Num inputs will keep track of how many input connections there are, and initially it'll be set to 0. Reporting inputs is a binary encoding of which of these inputs have data, and that will also be initially set to 0. Compare inputs full is a binary encoding of what reporting inputs will look like when each input connection has data. We will also have an ordered dictionary called input nodes. Remember, in order to use the ordered dictionary, we need to import the collections module. Ordered dictionaries really have 3 pieces of information for each element. They have the index number of the element, they have a key, and they have a value. In our case, we'll use all 3 of these pieces of information. The index number will represent which connection the node is connected to. The key value, node, represents the object node itself. And data will eventually represent the weight associated with any incoming information on this connection. For each of these internal input objects, there will be a corresponding output object as well with the same functionality. This may seem like a lot of duplication, and in fact it is. We're going to end up duplicating a lot of the codes in our methods. Ideally, we would just have one generic set of these objects, like maybe number of connections, reporting connections, compare connections full, over here, node connections, or something like that. But I think for the purposes of learning this, it's going to be more clear to use 2 sets of objects. But for extra credit, one of your possibilities will be to make this code more compact by combining all these objects into more generic objects. We need to create some methods also for our multi-link neurode, and one of the methods is going to be called clear inputs. It won't take any parameters other than self, and basically what it's going to do is empty the dictionary, actually instantiating a new empty dictionary, and it's going to set the number of input nodes to 0, and also clear out that compare inputs full object. A second method that our multi-link neurode will have is add input node. Add input node will take a single parameter node, of course in addition to the parameter self, which I didn't indicate here. Add input node will add a node to the dictionary, increment none inputs, and recalculate reporting inputs full. Recalculating reporting inputs full involves calculating a power of 2, which is a little bit expensive, so we'd rather do that just once when we're setting up the neurode rather than every single time we pass through with a training sample. Another method that we'll implement is called clear and add input nodes. It will take a list of nodes this time, call clear inputs to make sure there's nothing on the input side, and then for each node in the list, it will run add input node. And then we'll have one abstract method called process new input node. We're implementing this as an abstract method, first to give you some practice with abstract methods, but also because we might have a slightly different model of neural network that has the same sort of node structure, but requires different setup for the node in terms of how the input and output nodes maybe process their data. So again, for each of these methods, there will be a corresponding output method. And again, for extra credit, you can make this more compact. Finally, for this assignment, we're going to create a subclass Neurode that's going to inherit multi-linked node. Neurode will add two new objects to multi-linked node. One of them is called myType, and we'll use the same types that we used for the layers, so input, hidden, and output. The other is called value, and value should be initialized to 0. In addition to providing accessors for each of these two objects, we want to implement the abstract methods from multi-linked node. Process new input node should generate a random number between 0 and 1, and then create a new dictionary element that will have the node as the key and the random number as the data. Remember that we had another abstract method, process new output node. In this case, we don't really need to do anything with that, but we do have to implement that method in order for our class to work. We'll just do process new output node and have that method pass.